In this short video, we are going to talk about multi-protocol gateway. If you are already aware about the multi-protocol gateway, feel free to skip it. You can understand a multi-protocol gateway in DataPower with this simple diagram. So you have a client to invoke a service present on the server, and DataPower sits in between. On DataPower, you create a multi-protocol gateway. The multi-protocol gateway acts like a proxy which sits between client and server. Why do we need a multi-protocol gateway, or why do we need such a proxy? Well, there could be several reasons. One of the reasons could be that, for example, clients are B2B partners and the organization does not want to expose its own server over the internet. So they want all the client connection to funnel through a single gateway where they can enforce security and other policies. And if at all these connections are clean and green, the connection will further get into the server. That's one reason. Another reason could be that client may not support the protocol that server offers. For example, the server could be an MQ server and client could be a simple REST client. Now, this client may not speak MQ protocol. So how would a client post a message on an MQ server? In this case, if MPGw is sitting between client and server, it can facilitate this. Clients can connect with MPGw over the protocol, for example, HTTP or HTTPS, and multi-protocol gateway can post message on the server using MQ protocol. Such type of setups are very common when we deal with mainframe systems. Writing a mainframe client is not an easy idea, and most of the clients that we deal with are HTTP and HTTPS oriented. Hence, these clients can interact with mainframe system with the help of such multi-protocol gateways. So that explains why we need multi-protocol gateway. Now let's talk about the anatomy of a multi-protocol gateway. You see here multi-protocol gateway and its component numbered as 1, 2, 3, and 4. The top right corner explains what they are. 1 is front-side protocol handler, 2 is policy, 3 is backend handler, and 4 is XML manager. In this case, if you go to a multi-protocol gateway, you will find all these objects, 1, 2, and 4, but you won't find an explicit object called backend handler. That's something logical in nature. But let's understand what they are. The front-side protocol handler is the face of the multi-protocol gateway. It defines how a multi-protocol gateway is going to look like. For example, if I create an HTTP or HTTPS front-side handler, clients are going to interact with multi-protocol gateway using HTTP or HTTPS server. So clients will perceive that they are talking to an HTTP or HTTPS server. But if I create a front-side protocol handler of type SFTP, clients are going to interact with it using SFTP protocol. And hence, clients are going to perceive that they are talking to an SFTP server. So, a multi-protocol gateway is a very versatile object. Point to note. A single multi-protocol gateway can offer multiple front-side handlers. So, a single multi-protocol gateway can act like an HTTP or HTTPS server. It can also act like an FTP or SFTP server. Now, we'll skip 2, but we'll go to 3. This is backend handler. This is logical in nature. You won't find an explicit object named backend handler in multi-protocol gateway or in DataPower. But this is embedded inside every multi-protocol gateway. This handler is responsible for talking to backend server. And there you can configure what type of backend server you are interacting with. It's an MQ, or it's a mainframe system, or it's an HTTPS server, what kind of server it is. It is possible to integrate with a wide variety of backend servers using multi-protocol gateway. This includes modern servers like Kafka and others. Sitting between 1 and 3 is object number 2, which is policy. A multi-protocol gateway policy is at the heart of it, and the purpose of this policy is to act like a placeholder where you, as a programmer, can define your rules that will process incoming messages coming from client or the responses that are coming from backend server. So imagine a client sending a message to a server. The client sent a JSON message. However, the server requires an XML. It is the processing policy, object number 2, which will convert this JSON to an XML and will send it to the server. So it is sitting between client and server, can intercept requests, responses, and errors, and you can do whatever you want to do with those requests, responses, and errors. So DataPower developers spend a lot of time writing this policy. Now we are forgetting about the fourth object, which is XML Manager. Though programmers rarely interact with XML Manager, but the role of XML Manager cannot be overlooked. What is the role of an XML Manager? Well, the primary role of an XML Manager is to act as a threat protection mechanism. If you send a bad XML to DataPower, a very, very big XML to DataPower, an XML that is referencing external XSDs which have further references, all these type of XML messages, this XML Manager would flag as a problem. These are some simple examples that I have taken. It has more sophisticated way of finding out which XML is malicious in nature. It also defines the maximum size of XML document that you can send to DataPower. Now its name might be a little misleading nowadays because XML Manager looks like it has capability only to deal with XMLs. But since DataPower can accept JSON messages as well, some JSON related threat protection mechanism is also handled by XML Manager. When do you need to tweak it? Well, you need to tweak the XML Manager in certain scenarios. Number 1, you are sending a very large XML document to DataPower, which DataPower doesn't accept by default. So you go to XML Manager and tweak there the maximum size of XML that can be handled. Same is true for JSON. If you have something related to caching that you want to cache on DataPower, the XML Manager is the place to go. Sometimes when backend requires some kind of credentials that you cannot supply with policy, XML Manager is a place where you can embed them. So these are some of the scenarios where XML Manager can be used. Remember that multi-protocol gateway can have other objects too. And all of these objects like front-side handler, policy, and backend handler can have their composing objects as well. But these are the primary objects that make up the multi-protocol gateway. Summarizing it again, a multi-protocol gateway object is sitting between client and server. Its job is to intercept client's request, possibly modify it, process it the way programmer defines, send it to the backend. Again, the backend server gives you the response, process it, modify it the way you want, and send it back to the client. That's the whole job of the multi-protocol gateway. Now that you have understood the composition of a multi-protocol gateway, its anatomy, you can instantly understand that other objects like web services proxy, XML firewall, and other similar objects have the same nature and have the same composition. They might be there because of different use cases and different reasons, but essentially they have the same composition, they have the same pattern, and they follow the similar way of working. That's pretty much it. Thank you.